In this video, we will show you how to find the intervals of increase and decrease. This will be the first video in a series of videos on increasing and decreasing functions. We use intervals of increase and decrease to sketch a graph of a function. To illustrate this idea, let's say we have the cubic function f of x is equal to 2x cubed plus 3x squared minus 36x plus 5. In order to sketch this graph, we can either take some values of x, say 0, 1, 2, 3, 4, and plug it into our equation and use those points to plot the graph. However, this will take forever. Instead, what we can do is find some tangent lines and connect them together to make a graph. Since this is a cubic function, we know that it might look something along the lines of this. So now that we have a general understanding of what our graph may look like, our first step to find the tangent is take the derivative of this function. So let's do that. The derivative of f of x is going to be, well, we're going to take each term, use the power rule to find the derivative. So we have 2x cubed. The derivative of this would be positive 6x squared. And we have positive 3x squared. The derivative of that would be positive 6x. The derivative of negative 36x is just negative 36. And the derivative of 5 is just 0. So therefore, our f prime of x is 6x squared plus 6x minus 36. Now that we found the equation of the tangent line, which we know is a parabola, as it is a polynomial of degree 2, we can now use this to help us sketch the original function f of x. We want to first create the regions that will break the graph into small parts so that it becomes easier to sketch. To find the regions, we need the x-intercepts. To find the x-intercepts, we need to factor the equation. So to factor, we are going to factor up to 6, and then factor the quadratic. And so now we find out that x is equal to negative 3 and x is equal to positive 2. So what does this tell us? This creates the boundaries for our regions so that we can figure out where our tangent increases and decreases. So we're technically finding the intervals of increase and decrease here. So the x-intercepts are negative 3 and positive 2. So therefore this is going to be a region, and so is this. So this would be one region, this would be one region, and this would be one region. The first region I have is over here, and this is when x, all the values of x, are less than negative 3. So my region of x is less than negative 3. In this region right here, these are all the values of when x is in between negative 3 and 2. So when x is in between negative 3 and 2. And finally, in this region over here, this is when my x values are greater than 2. So I want to know what happens to my tangent line at each of these regions. That is, figure out if my tangent line is positive, so if my line looks like this, or if it's negative, meaning my line looks like this. To figure out what direction my line is going in, I would have to plug in a value for x that exists in each region and see if I end up with a negative number or a positive number in the equation 6x squared plus 6x minus 36. Let's take a look at the region where x is less than negative 3. So I'm going to choose a number that's less than negative 3, so say negative 4, and plug it in to my f prime of x. So we have 6 times negative 4 squared. That's 6 times negative 4 minus 36. And when I evaluate this, I get a positive number. So because I ended up with a positive number, my tangent line is going to look like this. So let's draw that in that region. So, like this. Now let's take a look at the next region here, where x is between negative 3 and 2. I'm going to choose 0 because it's easy to work with. So if I plug in 0 into f prime of x, I have 0, 6 times 0 squared, 6 times 0 minus 36. And so I'm just left with negative 36. So because this is a negative number, my tangent line is going to look like this. So let's draw that.
So because we're just sketching, it truly does not matter what the slope of the line is. It's just as long as if it's pointing in the upward or downward direction.
And finally, we're going to plug in a value of x that's greater than 2 into our equation. So let's just say I choose 3. So f prime of 3 is equal to 6 times 3 squared plus 6 times 3 minus 36. And I end up with a positive number. So my tangent line is going to look something like this. So let's just draw that. So we know that our graph isn't actually supposed to look like this. It should be a little bit more smoother. So let's redraw this. So that our graph is a bit more smoother. So remember that our graph is increasing. Our function is increasing when x is less than negative 3, and then decreases when x is in between negative 3 and 2, and then increases again when x is greater than 2. So therefore, again, our function increases when x is less than negative 3 and when x is greater than 2, and decreases when x is in between negative 3 and 2.
Let's do another example. So say we have f of x is equal to 1 over 3x cubed plus 4x squared minus 9x. And we want to find where the graph is increasing and decreasing, as well as sketch the graph. Our first step is to find the derivative of this function. So we are going to use the power rule for each term of this function. So we have 1 over 3x cubed, positive 4x squared, and negative 9x. So the derivative of 1 over 3x cubed is positive x squared. The derivative of positive 4x squared is positive 8x. And the derivative of negative 9x is just negative 9. So this means that my derivative is f prime of x is equal to x squared plus 8x minus 9. So my next step is to find the regions that will help me show where the graph is increasing and decreasing, as well as sketch the graph. That means finding the x-intercept. To find the x-intercept, we need to factor our derivative. So here we have x squared plus 8x minus 9. So let me rewrite this. Plus 8x minus 9. Set that equal to 0. And if we follow the method that was in the other video, so the video is linked in the description box below, we find that we get x plus 9 and x minus 1. And so our x-intercepts are negative 9 and 1. So to illustrate this, we have this boundary created over here at -9 and this boundary created at 1. So I want to know what's happening in this region over here where all of my x values are less than -9. I want to know what happens in this region over here, so whether my function is increasing or decreasing, for x values between -9 and 1. And I also want to know what's going on in this region over here where my x values are greater than 1. So just like how we did last time, we're going to plug in the numbers from each region into my derivative to see if I get a positive tangent, so a tangent that looks like this, or a negative tangent, a tangent like that looks like the second one I drew. So I'm going to first choose a number that where x is less than -9 and plug it into my derivative. So let's say I choose 10, -10. So I'm going to plug this into my f prime of x, which gives me -10 squared plus 8 times -10 minus 9, which gives me a positive 10. Therefore, my graph in this region is just going to be pointing up. So in this direction like that. Then I'm going to go into my second region. So that was where x is between -9 and 1. So for x is in between -9 and 1. So I'm going to choose x to be 0. So once I plug that into my derivative, so I have 0 squared plus 8 times 0 minus 9, which just gives me -9. Therefore, my graph or my tangent line is going to go down in this region. So like this. And then finally, we're going to choose an x value that is greater than 1. So let's say 2. So I'm going to plug that into my derivative. So we have 2 squared plus 8 times 2 minus 9, which gives me positive 13. And therefore, my tangent line is going to look like this. It's going to go up. So therefore, my function increases. So it's positive when x is greater than 9, and when x is less than -9, and when x is greater than 1. It decreases when it's between -9 and 1. So anytime we get a positive number, the function increases. Anytime I get a negative number, the function decreases.